Hello everyone and welcome to Lab to Lecture. Today we are going to discuss topic 2, atoms, elements and compounds. Let's get started. Question 1. The table shows the melting points, boiling points, and electrical conductivities of 6 substances, D to I. Identify the substance from D to I which has a macromolecular structure. Macro means giant. So we need the structure to be giant, and molecular means covalent bonding between atoms. So if you look closely here at these substances, you're going to exclude I, because as you may see, low melting and boiling points, and also you may exclude H and G, because relatively G has lower melting and boiling points. So we're left with 3 options, maybe D, maybe F, or I. If you look at D, yes, it has high melting and boiling points, but it conducts electricity when solid or liquid. So that's giant metallic. So D is giant metallic. If you look at I, while having high melting and boiling points, it conducts electricity only when liquid, but not when solid. So that's giant ionic. Giant ionic or ionic compounds conduct electricity only when liquid, molten, or when dissolved in water. But the one that has high melting point and high boiling point and does not conduct electricity whether solid or liquid, that's the choice F. So the answer here is F. And the reason for that, once again, because F has high melting and boiling points. Remember, giant molecular has high melting and boiling points. So that's giant molecular. And the second reason for that, from the right part of the table, that substance does not conduct electricity when solid or liquid. Next question. Information about atoms and ions A, B, and C is shown in the table. Complete the table. So in atom or ion A, this is the symbol of it. And as you may notice, it has 2 positive charges. It's a positive ion or cation. So you expect the electrons to be fewer than protons. We have 20 protons. We have 18 electrons. The difference is 2. That's why it's 2 positive charges. And the number of neutrons, you can get it by subtracting the proton number from the mass number, and that gives you 22. Atom or ion B, chlorine 1735. So 17 down below, once again, it's the proton number or the atomic number, so 17 proton number. And since it's an atom, it should also possess 17 electrons. Finally, C. First, let's look at the number of protons, 16, number of electrons, 18. They are not equal. Negative electrons are more than the positive protons. That's why you expect to have 2 negative charges. But what element is it? You have to use the proton number and check the periodic table. So from the periodic table, an element with the proton number 16, as you may see here, that element is sulfur. So sulfur is the element that has a proton number 16. So the element is sulfur. However, it's an ion with 2 negative charges on it. And you may write the proton number down below, 16, and the mass number up there. When you add neutrons to protons, it's going to be 32. Next question. 3. Potassium is a group 1 element. Potassium combines with sulfur to form an ionic compound, potassium sulfide, K2S. Give 2 physical properties of ionic compounds. So the two properties of ionic compounds that we know, they have high melting and boiling points. Also, they do not conduct electricity when solid, but conduct electricity when liquid, I mean molten or aqueous. So they do not conduct electricity when solid. However, they conduct electricity only when molten or aqueous. Aqueous means dissolved in water. Next question. Ester Y has the structure shown. Complete the dot and cross diagram to show the arrangement of electrons in a molecule of ester Y. We are going to make bonds between atoms according to that given structure. So as you may notice here, between carbon and hydrogen, the bond is a single bond. Remember, a single bond means a shared pair of electrons between the atoms. So carbon here was given as a dot. It means the electron of carbon has to be always a dot. So here we have a dot from carbon, and now that hydrogen has to be a cross. And just one dot and one cross, one pair of electrons means you have a single bond between them. Now, if you look here closely at the bond between carbon and upper oxygen, it's a double bond. It means you should have two pairs of electrons. So from each atom, you should have two electrons shared. So from carbon, I'm just going to use two dots. Remember, carbon is always dots. And from oxygen, I'm going to use two crosses. So overall, we have 4 electrons or 2 pairs. We have also to complete the octet of oxygen. Oxygen, if we look here at the periodic table, oxygen is group 6. It means it has 6 outer shell electrons. We've used just 2 of them in making bond between oxygen and carbon. So we still have 2 more pairs of electrons that have not been used yet. So the overall number of electrons around oxygen is 8 electrons. Now let's move to the bond between carbon and oxygen. So also, as you may see here, the bond is a single bond between carbon and oxygen. It means we should have a pair of shared electrons. So that carbon is going to use a dot and a cross from the neighboring oxygen shared between them. Now let's move to the oxygen to the right of that carbon here. So as you also see, we have a single bond between oxygen and carbon. So we should have another pair of shared electrons between them. Now oxygen is cross and the neighboring carbon is a dot. Now, before we move into carbon, now let's count the number of electrons around oxygen and satisfy the octet of it. We have 2 electrons shared from the left side, 2 electrons from the right side. So we still need 4 more electrons, and that actually matches with the number of valence electrons or outer shell electrons of oxygen from the periodic table. Since it's group 6, it has 6 outer electrons. We've used 2 of them in bonding. We still have 4 more electrons, so we have 2 pairs of electrons. Now let's move to carbon. Carbon has 3 single bonds with 3 hydrogen atoms, and that carbon is using dots for its electrons. So once again, we have a dot here from carbon, a cross from hydrogen, dot from carbon, cross from hydrogen, dot from carbon, cross from hydrogen. If you count all the electrons around that carbon to the right, you're going to find there are exactly 8 electrons. Next question. Question 5. Atoms and ions are made of small particles called electrons, neutrons, and protons. Complete the table. A neutron has a relative charge of 0, while it has a relative mass of 1. A proton has a relative charge of positive 1, while it has a relative mass of 1. Next, question 6. A carboxylic acid Y has the structure given or shown below. Complete the dot and cross diagram to show the arrangement of electrons in a molecule of carboxylic acid. So once again, we're going to use the structure to complete the dot and cross diagram. So if we start here with the bond between carbon and hydrogen, it's a single bond. So we should have dot and cross. And between carbon and oxygen, it's a double bond, so we should have 2 dots and 2 crosses. But before we move to the neighboring atom, let's count the number of outer electrons for oxygen. Now, oxygen is using crosses, and we have 2 of them in the shared area between oxygen and carbon, so we still need the rest of the outer shell electrons of oxygen. Remember, oxygen has 6 outer shell electrons, so we have 2 more pairs of unshared electrons. So overall, oxygen has 8 electrons in the outer shell. Now let's move to the bond between carbon and oxygen to the right of it, which is a single bond. So we need to use a dot and cross. And to the right of oxygen, we have a single bond with hydrogen. So we have another dot and cross. Now this oxygen still needs its 4 outer electrons. So we have 2 pairs of electrons that should be shown in the outer shell of that oxygen. Next question. Potassium is a group 1 element. Potassium combines with sulfur to form an ionic compound, potassium sulfide, K2S. Complete the dot and cross diagram to show the electron arrangement and charges of the ions in potassium sulfide. So here we have a dot and cross diagram of an ionic compound. Here we have the potassium ion, and if you look at the periodic table once again, you're going to find that potassium has 19 overall electrons, and potassium is a group 1 element, as was mentioned in the question down below. So here we have 2 electrons in the first shell, 8 electrons in the second shell. So we still need 1 more shell, and that shell will possess 8 outer electrons. So here we have 8 dots. Now overall we have 18 electrons because potassium has lost an electron and it turned into 1 positive cation. The exact same thing in that potassium ion. So once again we have a third shell that's full with 8 electrons, and we have 1 positive charge. Remember, sulfur has an overall 16 electrons. So in the last shell of sulfur, we still have 6 electrons from sulfur. So sulfur is represented by crosses. So we have 6 crosses. And to complete that outer shell, we need 2 more electrons, and those 2 electrons have been gained from the 2 potassium ions, but you have to represent them as dots because those 2 electrons have been gained from the 2 potassium atoms to turn them into potassium ions, and now sulfur has 2 negative charges because it gained 2 extra electrons. Question 8. Diamond and graphite are different solid forms of carbon. The carbon atoms in diamond and graphite are arranged in different ways. Remember, we have a difference between structure and arrangement. The structure of both diamond and graphite is giant molecular, but the arrangement is different. As we said before, diamond has 3-dimensional arrangement in tetrahedral form, but graphite has layer arrangement or layers arrangement. And within each layer, carbon atoms form hexagonal rings. So in the first part, state the number of covalent bonds each carbon atom has in diamond. Remember, each carbon atom is bonded to 4 more carbon atoms in 3-dimensional arrangement. State the term used to describe the structure of a diamond. Both diamond and graphite have giant molecular. Next, name an oxide that has a similar structure to diamond. Remember, that's silicon 4 oxide. So silicon 4 oxide. Or you may write it as silicon dioxide. Next, describe the arrangement of atoms in graphite. Yes, here he's asking for arrangement, not structure. Structure is giant molecular, but arrangement, as we said before, atoms are arranged in layers. And if you look here at the marks, it's 2 marks. It means you have to mention something else. And that is how atoms are connected, or the shape where atoms are connected to each other within each layer. So within each layer, carbon atoms are connected in hexagonal rings. So hexagonal rings. Next, explain how graphite conducts electricity In general, conduction of electricity happens due to the motion or movement of charge carriers. Charge carriers are whether ions or electrons. In graphite, the charge carriers are electrons. So the reason here, because of the motion or movement or having free delocalized. The word delocalized means mobile electrons. So the charge carriers here clearly are stated as they are electrons, they are not ions, and those electrons are not used in bonds, they are not fixed, they are delocalized or mobile. Now, this question is just 1 mark. If it's 2 marks, then you have to tell me that each carbon atom in graphite has 1 electron that is not used in bonding. That's why the structure has 3 delocalized mobile electrons. But since here it's just 1 mark, you don't have to mention the idea of having 1 free electron for each carbon atom. Next question, question 9. Complete the dot and cross diagram to show the electron arrangement and charges of the ions sodium oxide. So if you get back to the periodic table, you're going to find that each sodium atom has 11 electrons. Now, this is an ion because all metals, like sodium, they lose electrons, and sodium has 1 extra electron in its outer shell. So that electron is going to be lost to form 1 positive charge overall for that cation, and the same applies here. But you have to complete that second shell with 8 electrons for each cation. So here you have to fill it with 8 crosses. Since here he used crosses, then you have to stick to that choice. So crosses here for sodium, and the same applies here for that second sodium cation. Now oxygen has 8 electrons, 2 of them in the first shell and 6 of them in the second shell. And since here he used dots for the first shell, then you have to stick to that choice. So here we have 6 dots, but 2 other electrons have been gained from the 2 sodium atoms. So here I should use 2 crosses. Now the outer shell is complete with 8 electrons, and since it's gained 2 extra electrons, it should have 2 negative charges. So that's an anion with 2 negative charges. The next question, question 10. Complete the dot and cross diagram to show the electron arrangement in a molecule of phosphorus 3 chloride, PCl3. Show outer shell electrons only. So first you have to check the periodic table to know how many outer electrons we have for phosphorus, P. Since phosphorus in group 5 of the periodic table, it should have 5 outer electrons. Just as a kind of hint to you, to know how many covalent bond each atom should make, just count how many electrons are needed to complete the octet or 8. So since phosphorus has 5 electrons, it needs 3 more electrons. It means phosphorus should make 3 covalent bonds. And since here you have 3 surrounding atoms, it means each bond has to be a single bond with that atom. I'm going to choose the electrons for phosphorus to be a dot. So I have 5 overall outer dots for phosphorus. 3 of them will be used in bonding with chlorine atoms, and 2 of them will remain unused. So I have 2 electrons that will remain unused, and 1 electron will be used in bonding with chlorine. Now each chlorine atom will use 1 of its outer electrons to make a bond with phosphorus, and the remaining 6 electrons will stay around each chlorine atom. Because as you know, chlorine is a halogen, and each halogen has 7 outer shell electrons. So 1 of them was used in bonding, and we still have 6 outer electrons unused. And the same here, 1 electron is shared with phosphorus, and 6 other outer electrons, we present them as 3 pairs. And the same here. 11. Potassium is a group 1 element. Name and describe bonding in potassium. Since potassium is a metal and it's just potassium atoms that are making bonds together, so metal atoms make type of bonding named metallic bonding. And description of metallic bonding is simply like definition of metallic bonding. So metallic bonding is described or defined as the electrostatic attraction between the positive potassium ions in a giant metallic lattice and a sea of delocalized or mobile electrons. That's the optimum definition or description of metallic bonding. And since this overall question is 4 marks, 1 mark to mention the correct type of bonding, and 1 mark to mention the correct attraction between species. So now it's going to be between positive cations and negative electrons, and 1 more mark to mention the idea of having giant structure or giant metallic structure, and 1 last mark to mention the idea of having delocalized or mobile electrons. So that's the optimum answer for this kind of question. And this question, by the way, it's very common in the exams. Question 12, the names of the elements of period 2 of the periodic table are shown. Identify the element which has only 5 electrons in each of its atoms. 5 electrons in the atoms. He didn't mention 5 outer shell electrons. It means the overall number of electrons should be 5. If you get back to the periodic table and you look to the element that has a proton number of 5, that's going to be boron. And remember, proton number or number of protons in an atom should be equal to the number of electrons. So the answer here should be boron. Next question, question 13. This question is about nitrogen. Nitrogen molecules have the formula N2, and he gave you some properties of nitrogen. Name the type of bonding between the atoms in an N2 molecule. Between 2 nonmetal atoms like nitrogen, the bonding is covalent or molecular. Explain, in terms of attractive forces between particles, why nitrogen has a low melting point. Remember, between molecules we have weak intermolecular forces of attraction due to the weak intermolecular forces of attraction between molecules. So you mentioned the strength, which is weak, and the identity of species that are making this attraction, which are molecules. So between one molecule and a neighboring molecule, they are connected through weak intermolecular forces. Explain why nitrogen does not conduct electricity. Remember, conduction of electricity due to the charge carriers, whether electrons or ions, and we have neither of them. So we have no ions or mobile electrons. Electrons exist, but they are not mobile. So we don't have the mobile electrons as a charge carriers. We don't have even mobile ions or ions in general. So that's why we don't have conductivity of electricity. Next question. Describe the bonding in a metallic element such as copper. So once again, metallic bonding, you may include a diagram. In a diagram, you should represent the cations as larger spheres. So here we have many of the larger spheres. You just draw as many as possible of them, and then you represent smaller dots between them to show the mobile or delocalized sea of electrons. And you have to label those larger spheres as positive metal cations and the smaller dots as mobile or delocalized electrons. And the description of that metallic bonding, once again, it's the electrostatic attraction between the positive ions in a giant metallic lattice and a sea of delocalized or mobile electrons. Next question. 2 isotopes of sulfur are shown. Use your knowledge of protons, neutrons, and electrons to answer the following questions. Describe how these isotopes of sulfur are the same and how they are different. So in terms of the number of protons, neutrons, and electrons, these 2 isotopes have the same number of protons, which is 16, and also they have the same number of electrons, which is also 16. Remember, protons and electrons in any atom should be equal, and he just mentioned that in the question to answer the question in terms of protons, neutrons, and electrons. So they have the same protons and electrons, but the difference comes in neutrons. So they are different in the number of neutrons. So one atom has 16 and the other atom has 17. Next, explain why each of these isotopes have an overall charge of 0. Because the number of positive protons equals the number of negative electrons. Explain why both isotopes have the same chemical properties. Remember, chemical properties come from the number of outer shell electrons. Since both isotopes have the same number of outer shell electrons, they should have the same chemical properties. Next question, question 16. Hydrazine N2H4 is a compound that contains nitrogen and hydrogen. Complete the dot and cross diagram to show the electron arrangement in a molecule of hydrazine. Show outer electrons only. He didn't give us any structure here in this question, but you have to check the periodic table and look how many outer shell electrons does nitrogen possess. Nitrogen has 5 outer shell electrons. To know how many covalent bonds it should make, then you have to look how many electrons are needed to complete the octet of nitrogen. Nitrogen needs 3 more outer shell electrons to complete the 8. So it means nitrogen should make 3 bonds. Since you have 3 surrounding atoms for each nitrogen, it means all of the 3 bonds should be single bonds. Now I'm going to pick dot. That's my choice for nitrogen. You may pick cross. It depends on you. So I'm going to pick dot for nitrogen. So a dot for nitrogen is shared with the cross from hydrogen to make the first single bond. And a dot from that nitrogen is going to be shared with another dot because they are exactly the same type of atom. And here a dot from nitrogen with a cross from hydrogen. Now, this nitrogen hasn't used 2 of its outer electrons, and remember, nitrogen is dot, that's why I'm going to leave here 2 dots that are not used in bonding. Now, overall, that nitrogen has 8 outer electrons. For the neighboring nitrogen, once again, it has 1 dot shared with 1 cross from hydrogen, and 1 dot from nitrogen with 1 cross from hydrogen, and 2 remaining dots that are not used in bonding. Overall, once again, we have 8 outer electrons. The next question, question 17. Sodium is a metallic element. Describe how solid sodium conducts electricity. Remember, conduction of electricity due to having mobile electrons or having mobile ions. Since here we don't have mobile ions in case of the metallic element, so it's just because of having mobile electrons. So due to having mobile or delocalized mobile sea of electrons, and also it's worth mentioning the type of structure within the giant metallic lattice. So the keyword here, mobile and electrons. Next question. Some properties of sodium chloride are shown. Name the type of bonding in sodium chloride. Since sodium is a metal, chlorine is a non-metal, so that's an ionic bonding. Explain why sodium chloride conducts electricity when molten. Once again, conduction of electricity could be due to mobile electrons or mobile ions. Here we're talking about ions. So due to having mobile ions or delocalized free ions. So ions are mobile in case of the molten state of an ionic compound. So ions are mobile, or you may say they can move freely. Next question, question 19. Atoms are made of protons, neutrons, and electrons. Atoms of the same element are known as isotopes. Magnesium 24, magnesium 25 are isotopes of magnesium. Complete the table to show the numbers of electrons, neutrons, and protons in these isotopes of magnesium. Remember, isotopes, they should have the same proton number, which is 12. So they have the same number of protons, 12 and 12 in both of them. And remember, always in any neutral atom, protons and electrons should be equal. So we have 12 electrons in both of them. But the only difference is in neutrons. So if you take the difference between 12 and 24, in that first isotope, it's going to be 12 neutrons in the first one, but 13 neutrons in the second one. Next question, explain why magnesium ions have a charge of 2 positive. To explain the charge of any ion, whether cation or anion, you have to compare electrons and protons, because electrons are negative, protons are positive. Since you have 2 positive charges, it means the ions have 2 more protons than electrons. So because the ions, or they have 2 more positive protons, that's why the overall is 2 positive than negative electrons. Question 21. Sulfide ions S2- have the electronic configuration 288. Explain why sulfide ions have a charge of 2 negative. Once again, the same idea, because they have 2 more negative electrons. So the answer is they have 2 more negative electrons than positive protons. So negative is more than positive by 2, that's why overall is 2 negative. Give the formula of an anion which has the same electronic structure as S2 negative. Remember, 2 negative means acquired 2 extra electrons. So I need the number of electrons to be exactly as in S2 negative. So first, let's look at how many total electrons we have in a neutral sulfur atom. In a neutral sulfur atom, we have 16 electrons. And since it's 2 negative, it means we have to add 2 to them. So now overall we have 18 outer electrons. Now we need an anion that would have the same number of electrons, 18. That could be chlorine. It has now 17. When it's -1, I mean when we add 1 to it. So the answer could be chlorine 1 negative. Or you may say phosphorus, which has 15, but since we need 3 more electrons, then the charge is going to be 3 negative. Okay, so the anion that would have 18 electrons could be chlorine 1 negative or phosphorus 3 negative. So any of these will give you the mark. And then he's asking you for a cation that would have the same number of electrons, 18. Cation positive, it means it has lost electrons, so we need something that has more than 18, and then there is a loss of electrons. So I may pick here the next element to 18 or argon, which is potassium, which has 19, and then I'm going to remove one of its electrons. So it could be potassium 1 positive, or you may pick the next element, calcium. Now calcium has 20, you need them to be 18. It means we should have 2 positive charges. It means losing 2 electrons. So the answer here is chlorine 1 negative charge, or you may mention any of them, by the way. You may mention phosphorus 3 negative charge. And for a cation that should have 18 electrons, that's potassium. When it loses 1 of its electrons, potassium has 19. When it loses 1, it becomes 18. Or you may mention an element like calcium when it loses 2 electrons. So when it's 2 positive cation. Well, I think that's enough for today. However, you have more questions to answer. Don't hesitate to get the whole PDF file for free. Just contact me. I'll send you the file. See you next time. Good luck.